will take is water on that. Second one, okay, we'll just test that. We'll test the polyatomic ion, those selected ions, and that test is called barium chloride test. That will expose, in particular, specifically, just one thing, sulfate. So that barium chloride test is going to expose these polyatomic ion, the sulfate. Okay, so we got carbonate, sulfate, phosphate. It is specific to the sulfate. It produces precipitate. Okay. But how would you tell the other, the carbonate and the phosphate? So by qualitative analysis, by looking at the solution and what develops in the solution. Okay. So hopefully you'll be able to tell the difference between. All right. So flip that page. Okay. So you want to write down, follow me with these. I'm going to perform all these experiments tonight on the spot. So you're going to follow me. There are plenty of chemicals, definitely. And hopefully we will not make any mistake. But for the time being, flip the page. So flip the page. I don't have a page number, but this is the beginning of that table be filled out. So this is must be page 74. So turn to page 74, and I'll be showing the following. So I have a replica. Okay, so this is a replica of that page. Okay, so I'll be checking for the existence of the chloride bromide iodide, so chloride bromide iodide, and for the polyatomic ions, so the replica are carbonate, sulfate, phosphate. So now my two unknowns, based on that matrix, based on that previous diagram, are located on these two sides. So this side, okay, so on your side, this is the left-hand side. This is unknown one. So I'll be adding, or I'll be inserting a tube to check on the unknown one for any given test. So if I'm testing for the existence of halide, I'll be doing all these 6 solutions, including unknown 1 and unknown 2. So unknown 2 is located on right-hand side. Okay, follow me? So this is the layout of my test tube holder. Okay, so we're going to follow the result based on these following diagram. Okay, do you follow me? So now, I guess, so I'll try to come up as close as possible to be able to tell the colors. So right now, I want to add the following. So I need to bring in some test tube, and I got plenty of those test tube. So I guess, so we're going to insert some of these test tube in here. Hopefully they would not fall. So it's not meant for a test tube holder, but I'm using it to have a clear picture of what's going on, because you need to see exactly what's going on. The test tube holder, which is that one, sort of kind of line the spot where you want to see what's going on. Okay. So hopefully they would hold. So you have 3 halides on this side, and on the other side I want to test the polyatomic ion. So you got 3 polyatomic ion and 3 halides going on this side. In the back end of the holder, so I have unknown 1 test tube and unknown 2 test tube. Okay. All right. So first off, we're going to perform the silver nitrate test. So in essence, these are qualitative. Okay, so we're not going to be measuring things as far as the quantity or what's known as quantitative. We want to just simply identify to tell whether or not we have halogen or halide, and if you have halide, what type, which one? Because you got either chloride, bromide, or iodide. So which one? The same as for the polyatomic anion, carbonate or sulfate or phosphate. So let me introduce these ions one at a time. So I have, I want to introduce the sodium chloride. So the first one is going to take on a chloride. Let me see, where is that sodium chloride? Okay,
Professor,
yeah.
is this meeting being recorded?
All right, so if you follow my, so I'd rather have you ready for me as far as the recording. Basically, some of you like will leave at some point. Just turn on recording and just fly by. So I want you to follow me. Okay. Is that fair?
No, I understand, but I'm just asking. Just
This meeting is being recorded.
Is a recording.
Thank you.
But typically, I'd rather have you just follow me and try to ask as many questions as possible. So so please stick around and follow me and ask questions. The main part basically is not just doing the experiment and the mechanic part, and then you figure out on your own. No. So I want you to ask all the questions that are possibly to be asked. All right. So first, I want to add the halide, the three halides, the chloride, bromide, and iodide. So I have sodium chloride. So I'll be adding maybe a small amount, a few drops. Be hardly maybe a milliliter. Okay, so roughly 1 milliliter. You don't need much. So this is just sodium chloride. Next, I want to add sodium bromide. Okay, so this is stop a little bit. Stop it. Let's prove it. So I want to add, so I have sodium bromide, small amount, just a few drops. And the third, maybe I switched them. So that was not sodium bromide. So that was sodium iodide, I'm sorry. So that was sodium iodide. And I want to add sodium bromide to that one. Sodium bromide right there. So this is sodium bromide. I don't have knife upper, so let me just add 2 drops. Okay, hardly a milliliter. Now to the other ones, so I want to add carbonate. Sodium carbonate. Okay, so what I have sodium carbonate here. Okay, sodium carbonate. So tube number 4, 2 drops of sodium carbonate. And next is sodium sulfate. So I got sodium sulfate. And then the last one is the sodium phosphate. So what works and sometimes what does not work is much better than what works. So what does not work for this experiment, what goes up against the result is contamination. So any contamination going on with those, that's the reason why they have to be clear and they're very clean in between all these tests. And test for tonight basically will be a replica of three times. So if I'm using 8, 3 times 8, 24. That's so typically generically. So we have two students to partner together, share their resources of their drawers, glassware, because it's not suitable one student. Otherwise, you're going to end up all day long just cleaning, drying, trying to come up with all these 3 tests. So I'll do the same. Okay, so I want to add 2 unknown ions in here. So I guess since the unknown ion so I guess I'll add it on the side. So this is unknown 1. Okay, so unknown 1 milliliter of that ion. And then I'll be adding unknown number 2. Unknown number 2. So I have unknown number 1 and unknown number 2 seated in the back of that stack. Okay, so any question about the layout? Just want exactly what we have on that sheet. Okay, so the first test is to expose the halides. Halide of any type, so that could have been fluoride, chloride, bromide, iodide. So any halide in the form of a negative ion, halogens basically are molecular, diatomic, let's say F2, Cl2, fluorine, bromine, these are all diatomic iodine. But then if they're found inside the water, a small portion of that molecule is going to dissolve, not all of it, because they don't like to be in the water, but they happen to be dissolving and submerging in the water by infusion. The outcome basically is a negative ion. So that particular test is to expose them. Okay, so it needs to be positive for the halides only. Okay. So I'll be adding, so the next part, so in here, just, so I'll be adding silver nitrate to all of them. Okay. So the test starts by adding small amount of silver nitrate. And silver nitrate basically has to be maintained inside tainted glassware, the amber look glassware, to prevent any possible interaction with light. So just a few drops, because I want to show you the solution. So a few drops of the, okay, so you know is the solution. So this is the first, so the chloride ion mixed with silver nitrate ion. So here's a bromide with silver nitrate. Okay, so pretty much kind of a similar result. And here's a few drops of iodide. Okay, so noting all these are pretty much similar. So if you notice, so here's the outcome of the 3 halides. So this is the chloride, the middle is bromide, the one on the right hand side is the iodide. So that's the result. Okay, so just make sure to write down the result as you see. I'm going to continue adding 1 drop or a few drops of that. I don't want to waste so much of it, just a few drops. So it takes 2 drops. So here's the carbonate. Okay, so the carbonate start to show me some kind of positive result initially. Okay, so that means I'm creating, because I'm adding silver nitrate in here to that carbonate, CO3 negative 2. The outcome is sort of a whitish background, cloudy black ion. All right, I'm going to add a few drops of the silver nitrate. Okay, so this one, so as you notice, I just want to show you the difference. So assuming, so I want to compare it to unknown one, which is unknown, should be clear one. So here's unknown, and here's the, can you tell the difference? Can you tell the difference? So this one is clear, transparent, and this one is clear but not so transparent, right? Yeah. Not really transparent. Okay, so this one is 100% same as the water. But someone said there's an ion, can't tell. So can you tell them? Can you tell apart?
Oh.
So this is upon the addition of silver nitrate to the phosphate.
Okay.
I'm sorry, to the sulfate.
Oh yeah, it looks like with the sulfate you can just see a slightly cloudy mixture, but it is less so than all the other four.
Right. So this is the comparison. All right, so now to the third, the phosphate, I want to add a few drops of silver. Okay, so notice the outcome. So can you see the outcome? Mm-hmm. So this is the addition of silver nitrate to the sulfate. This addition of silver nitrate to the phosphate. Okay. And so these are the polyatomic ion addition. And here is the addition of silver nitrate to the carbonate. Okay. So you can tell them apart. So compare all these. I want to hold them correctly. So compare these. So compare these to this original color. Okay. So just make sure you note exactly what we have. So the first one is the carbonate. Second is the middle one is the sulfate. The last one is the phosphate. That's the outcome upon addition of the silver nitrate. Now I want to add the same. I want to add to these to the test of the same thing, which is 2 drops of the silver nitrate, 2 drops of silver nitrate. So I have so on the left-hand side. So from your own perspective, the left-hand side, right behind that chloride, I have unknown 1, and right behind that phosphate, I have unknown 2. Okay, so to unknown 1, I want to add same, so 2 drops of the sulfur. Okay, so here's the outcome. And I'll do the same. I'll be adding 2 drops to that unknown 2. And just add 1 more. Unknown 2. Okay, so it has that shade, that color, that outcome. All right. The last part of the silver nitrate, the one that would expose only the halides, is to add some acid. So definitely we want to avoid anything that has to do with chloride or sulfate or anything. So I want to come up with sort of a NO3 nitrate thing, so nitric acid. So I want to add nitric acid, but needs to be with high molarity. I don't have much of that high molarity, so just that's what I have, basically just half a molar, which is sufficient, but then I need to add a good amount. So instead of adding just like a few drops, so I want to add a few drops of the 6 molar, supposedly 6 molar of nitric acid across. So whatever that amount of the added material, which I was using 1 milliliter, so I need to add replica of nitric acid. So here's the nitric acid. Okay. So nitric acid, okay, didn't do much. Okay. So the bromide test tube, I want to add the same thing, nitric acid. I want to add nitric acid. Third, nitric acid. Okay, so bad and has so just expose my solution. So either the test tube was contaminated, or the solution itself is being contaminated. So let me add another. So we had on the third one iodide. So let me just add iodide. Just a milliliter or so. Remember, we added a milliliter of iodide, and then I want to add maybe 2 drops of silver nitrate. So that's the outcome with the iodide. And then I want to add, and after that, I want to add nitric acid. Okay, so this is the outcome upon the addition of nitric acid to the halide. So they sustain their own precipitate. So that precipitate, that white background, that precipitate remains to be in solution. Now I want to add nitric acid to those. So once again, the molarity of it may not help, but let's hope for the best. I'll do the same for the unknown. So in here, let me just shake it. Okay. So it used to be, remember, it used to be a solid. The carbonate formed silver carbonate solid precipitate, and doesn't seem to hold. So upon addition of 0.5 molar, has to be 6 molar, 6 times the strength of that solution. I run out. I don't have 6 molar. But look what happened. So the solid is gone. So maybe if I add maybe 2 drops, of that, so just add maybe another shot. So just add a little bit more of that. I don't have enough of nitric acid, but look what happened. Okay, so this is the addition of the, so compare that to those halides. So this is iodide, okay, and this is the used to be carbonate, so it's clear. Now I'll do the same. So this is used to be sulfate, remember? Used to have some solid. Okay, so this is sulfate. Let me add maybe 2 drops of the nitric acid. Thank you very much. But obviously, it's a little bit more clear. Okay, so whatever that sulfate, okay, it's a little bit more clear. The same as, so all these solids that develop, remember the phosphate, the silver phosphate, okay, that sort of start to structure and develop as yellow crystals. So it's gone. Okay, so that solid is completely dissolved and gone. Okay, so I'll do the same. I'll be adding silver nitrate, nitric acid. I'm sorry. So nitric acid to unknown one. So it's the unknown one, nitric acid addition. So that solid maintained, did not go away. So that solid for the unknown one remains. Okay, resembles. Okay, so we don't have much of saying. So these are all halides. These are all polyatomic carbonate, sulfate, and phosphate. And unknown one sort of, upon the addition of the nitric acid, produces the following. I want to add the same thing, a few drops of the nitric acids, but I'm using sizable amount because I don't have 6 molar. So this is the addition. Comes a little more clear. I guess. So I have just a few drops. Like I got my dropper with a few drops of the salt, 6 molar, but I don't have much of it. Okay, so, but obviously the solution is turning to be a little more clear than the previous. So previously it has some sort of a solid or sort of a cloudy background and start to clear up a bit. Okay, so this is the outcome of unknown 2. So unknown 1, with the silver nitrate test, they expose the halide, produce cloudy solution, similar to those the first 3 set test tube. So that is similar outcome, as obvious. But then the second unknown, I guess, resembles that much the same, those 3 tested. So this is the first quest of figuring out the unknown. So record all these results in here. So you got 8 columns. Okay, so last ones are for the unknowns. So write down the result with respect to the after the addition of nitric acid. So first, what happened when I added a few drops of the silver nitrate? What happened? Which one produced outcome? What sort of color? And then which ones that retain their precipitate with what sort of color? And which ones that are solid, or that whatever that precipitate, whatever that cloudiness is gone or faded out. Okay, so that will complete the first silver nitrate test.
All of the ones that you've done so far, it looks like there's a distinct coloration difference in between the first 3 and the second 3, but they all pretty much look the same from the zoom camera.
Yeah, so they all looked the same. But remember the step right before the addition of the acid, they look different. So if you notice, the carbonate doesn't have the same as the look of the sulfate. The first addition, when I've added silver nitrate, and I added silver nitrate and I'm showing you the color and the outcome, they don't have the same exact outcome. Now they have the same as, they all have pretty much the same outcome. Okay, so that's their outcome. So this is the outcome of these. Kind of resemble each other as far as the outcome. Can't tell them apart. Okay, so the first test tube is the carbonate, the middle one is sulfate, the last one is phosphate. So upon the addition of the nitric acid, now they resemble each other. That's the final step. But the step before it, they differ. Okay, so just remember exactly their colors on the first step of the addition of the silver nitrate. Okay, so that's that. And these are the unknown 1 and unknown 2. Okay, so I'm going to follow up. So this is what conclude the first step. So where there's a solid line, so there's the solid line. Okay, that solid line means clean all these glassware, position them the way they are based on that matrix, based on the layout shown, and then add to them the same chemicals, the same anions. I'm going to replicate the same thing. So, but I have plenty sets of those test tubing. So I'm going to put these on the side for a second.
Professor, how are you cleaning them to make sure there's no contaminants left?
Okay, so to clean them, basically, if you happen to be in the lab, so I want to, well, I guess because we partner 2 students typically, so one student will keep on washing the glassware. Yeah, so that becomes your project, and your partner basically is doing the testing, and you keep backing up your partner with the fresh and clean glassware. So it becomes an exercise of like more than an hour or so of cleaning all these test tubes and make sure there's nothing, no remnants, no impurities, nothing remains of the previous runs and tests and ions. Once you have slight contamination, all the tests would not have whatever they anticipate. Okay, they would not be true as far as the result. So I guess, yeah, so one of you will be busy for 1 hour washing and cleaning the glassware. So that becomes the exercise for the day. Okay, but so instead of having just one student doing it, otherwise it will take maybe 3 hours. Okay, by the time you wash them, clean them, make sure these ready for the second shot, for the second test, because you have 3 separate tests. Okay, so the first test is for the so it's test to explore the halides, and we did. So it is positive for the halide, obviously, which is solid precipitate. Now, but negative if you have polyatomic ion, carbonate, sulfate, and phosphate. Negative. Okay, so you did not have. So whatever that solid that would be there is gone. So that's negative for that test. So the second part, I want to just refresh all these test tubing. Okay, so I have plenty of those clean test tube. All right. So back to unknown 1, unknown 2. So let me just position them on the side. And here's the atomic ions. Here's the halides. All right. So back again. So on the second run, as you notice, for the second run, I want to perform barium chloride, which is exposing. It is positive specifically for the specific polyatomic SO4. So that one will expose the SO4. Okay, go back to the same matrix as before, the layout. So I'm going to add fluoride, bromide, iodide, carbonate, sulfate, phosphate, unknown 1, and unknown 2. All right, so I'm going to add fluoride. Just 2 milliliters of the chloride, and then bromide, good enough. And I want to add iodide. Alright, so easy iodide. Next, the carbonate. Sulfate. Phosphate. So slight contamination, you end up with absolutely no result, and the result would not make sense any longer. All right, so now we're going to start with unknown 1. So let me just hide it for a second. So this is unknown 1. And then unknown 2. So I have unknown 1 and unknown 2 on this side. All right. So the next is we want to perform the test, which is specifically for the polyatomic ion SO4 -2. Specifically is positive for the sulfate. Okay. So I'm going to add So it says here, just add barium fluoride. And use barium fluoride. So I want to add 2 drops of barium fluoride to each. Just so if I add barium fluoride, that chloride solution. So it is chloride, so this barium chloride, and this one has chloride, and look what happened. So chloride to the bromide. Barium chloride. So I got carbonate with the chloride. Okay. So notice what happened. Okay. So this is the carbonate that used to be clear. So that's the carbonate, and that's the carbonate upon addition of barium fluoride. So that means barium carbonate is formed. That's a solid. So we add 2 drops of the barium chloride. So this is the sulfate. Okay, once again, so here's the outcome. You can see it. So it's the addition of barium chloride to sodium carbonate. Is addition of barium chloride to the sodium sulfate. That's how they look. Now I want to add barium chloride to the faucet. So pretty much the results are pretty much okay. So pretty much they end up with almost similar results. They all kind of produce in sort of there's an outcome. There's a reaction definitely. Okay, so they vary with the intensity of those particles. So some of them are obviously more cloudy than others. Now to unknown one, I want to add 2 drops of the barium chloride. Okay, and there is nothing. So unknown 2, I want to add 3 drops of the barium chloride. So the outcome basically is so obvious. Okay, so this is the unknown 1. After the addition of barium chloride, unknown 2. After adding barium chloride. Okay, good. All right, I want to acidify, because that test, barium chloride test, is specifically for the sulfate. So I want to add a harsh acid. So to complete this, the test of barium chloride test, basically to expose the sulfate polyatomic. So I want to add harsh, high molarity hydrochloric acid. So we got 6 molar hydrochloric acid. So I want to add a few drops of that 6 molar. This is the chloride. Here's the acid. And there's nothing. Here's the bromide with 2 drops of the acid. And the iodide with 3 drops of the acid. Okay, so they all kind of produce the same background, which is okay. So this is sort of the outcome of these halides. So the halides are negative to that barium chloride test. So let's see which one's going to turn to be positive. So let me add acid. Okay, and now solution cleared. That used to be the carbonate. Remember carbonate? I've added barium chloride to it and I formed some solid. Upon acidifying that solution with 6 molar acid, okay, it turns into clear solution. So this is clear. The carbonate is gone. Now let me test the acid addition to the sulfate. So here's the sulfate, and here's the acid. Okay, so the cloudiness remains. I agree. So we're also to the carbonate. So here's the carbonate. And here's the sulfate. This is the sulfate, and this is the carbonate. Carbonate, sulfate. Now I'll do the same. So here's my phosphate. So there's sort of a cloudy solution. let's see upon the addition of a few drops of the acid, and it turns into clear. Okay, so solutions are clear readily. So carbonate clears, phosphate clears. What turns out to be positive for that test, even though with the harsh acid, the sulfate. So barium sulfate resilient resist to dissolve. Now I'll do the same for the unknown one. Okay, let's see what sort of thing. So far it's clear. There's nothing. I guess if I add the acid, I don't know it's gonna do anything. So here's the acid, nothing, negative. And now to unknown number 2. So notice number 2 has a cloudy structure. Okay, so here's the addition of the acid. A little more, just to make the point. So this is unknown 2. So it doesn't matter. So unknown 2 sort of resist the dissolve. Okay, so this is unknown 2. So this is unknown 1. So the barium chloride test to expose the sulfate produces negative for unknown 1, positive for unknown 2. All right. So that will conclude the second test. The one that is specific for the sulfate. Okay, so and here, so it's not really preferential. It does not distinguish. Cannot tell whether or not you have carbonate or whether or not you have phosphate. So it is only specific for the sulfate. Sulfate is a positive outcome of that addition of or doing the barium chloride. Barium chloride test basically is positive only upon the addition of the acid. So they all produce some solid at some point by the addition of barium chloride, but then the middle one remain to be positive. The other two are gone and negative. So I guess you can detail exactly the carbonate and the phosphate before and after, as far as the particles and texture, which one has more cloud, which one has less cloud, and so on. Well, typically, based on the previous tests, remember the silver nitrate test, expose the phosphate. So silver phosphate has a unique sort of a hint of yellow to kind of there's sort of a yellowish in the background of that solid that makes it so unique. Okay, so you start with the silver test and reduce that color first. Well, there's something going on that has to do with the phosphate. Okay, so that's the second part, and it's all complete. So we check on the barium chloride for the existence of the sulfate, and that part is done. So we're going to move on and clarify or trying to figure out, okay, what's going on as far as unknown 1, unknown 2 for the last part, which is known as the chlorine test. The chlorine test basically is, specify which ion do I have, which negative monatomic ion. Do I have chloride? Do I have bromide? Do I have iodine? The way it works is the following. So let me get rid of these. So the way it operates is the following. Let's push these on the side for now. So before I start that test, okay, so what I have is 3 test tubes. So what I have in them, so the first test tube I have chlorine and water. So there's a chlorine, Cl2 with water. Definitely chlorine is molecular and resists to infuse in the water. So here's the chlorine. Here's a picture of that chlorine, basically, sort of a hint of yellow. Once in the water, it doesn't like to be in the water, but you can just keep depressing it and push it in to infuse it. Eventually, a portion of it will be infused. The minute you uncap that bottle, will escape automatically, because chlorine at room temperature tend to be gas, okay, would not remain in the water. So once you open that bottle and try to scoop a small amount of that chlorine, a good chunk of that chlorine that was infused and found in the water is going to try to escape. So at the beginning of the class, let's say if your friends are not careful, and especially if they kept that bottle open, of that chlorine in the water open, what's going to happen? At the end of the class, there's nothing left of that chlorine, only water. And that would just clear solution just like this. So what if that hint of yellow is gone, means you don't have any longer any diatomic chlorine, any halide, any Cl2, all the escape. If you have small amount of that chlorine with some organic, let's say I got organic layer hexane, the mixture is the following. Hexane is lighter, less denser. So the layer up on top is going to give us the environment where the chlorine Cl2, the organic molecule Cl2, would love to be in. So Cl2 prefer and favors the organic environment, hexane, don't like to be inside the aqueous solution. So the way it is right now, it's not really happy, and I'm very upset. The reason why the mint you uncap that bottle is going to escape. Or you can just add organic. So I've added organic. So initially I start with a small amount of that chlorine water, but I've added organic. So the color of it sort of either you can figure out, I don't know, how to, is there any hint of yellow or anything? Hardly, right? So this is what's left of that, whatever that faint yellow color, hardly any color, either clear or maybe there's a hint of yellowness. Can you see that hint of yellowness somewhere? So the layer to check all time, the bottom layer is the aqueous, the more denser, the heavier. The lighter of that layer basically is the organic layer, hexane, and in it you're going to find a tremendous number of chlorine molecules infused. So they're going to migrate from the aqueous, and they're going to migrate towards the hexane, and to be found in a good number of them. So that's the color of hexane and that's the color of chlorine in the hexane. Okay, so either you can say, well, clear, because I can't see that hint of yellow, or sometimes you can detect, depending on how sharp your eyes. Can you see that hint of yellow in the hexane layer, in the top layer? Maybe or maybe not, because I can't see it. Okay, so that's the chlorine and hexane. Now, bromine hexane. So bromine once again, so is the bromine solution. Bromine solution is sort of a little more reddish, rusty reddish. But then once you add hexane layer, good number of that bromine will escape from that lower layer, the aqueous, into the organic, because it prefers to be in the organic. And the color of it is sort of can you see that background color of it? Okay. So this is the background of the bromine, and that's the background of the chlorine. Always look at the top layer. And here, I don't know if you can see the two layers. Can you see the two layers? Can you see that sort of a transparent or sort of a shade? So this is where the cutoff between the organic layer, top layer, and the bottom layer is the aqueous. Can you see it? Can you see the two layers?
Yes.
There's a line, okay, where the line happens. That's the divider between the top layer, organic, and the lower layer, the aqueous. But it is a little bit more clearer in the case of bromine. Okay, so that's the bromine. The bromine has sort of a orangey to rusty color. The top layer is the bromine inside the hexane. The last of the halogens is the iodine. So is the color of the iodine split between the aqueous solution and the organic solution hexane. So the iodine has sort of a very unique color. So is the iodine compared to these are much better. So this is much better comparison side by side. So we call these test tube. Can you see them? So we call these test tube control test tube. Control means every time you want to figure out things, so what's happening, you go back to them, reference the colors in them. Okay, so these are the control, and keep them all day long as a backup to check on the rest of the other activities. All right, so the next one, so the logistic or the idea of the chlorine test is the following. So if there is an iodide, if there's a bromide, if there's chloride, chlorine test is sufficient to tell them apart. It's going to expose them. Okay, how? So you follow me with this concept. So chlorine test is going to expose what sort of halide there is. Okay, so assuming you have the following. So let's assume that we have, let's say chlorine. So say if you have, let's say, chlorine, and you want to mix it, so I'll mix that chlorine. It's always diatomic. I want to mix it with, let's say, bromide. Let's say sodium bromide. So sodium bromide. Okay, so a solution of chlorine with sodium bromide. If there is a reaction, if there is an outcome, there's product, okay, what must have occurred? I guess the sodium is going to come in next to that chlorine. It's going to break open that chlorine, that diatomic, and makes the sodium chloride, and the bromide becomes bromine. So there's a negative charge in here, positive charge in here, and there's no charge in here, just molecule. So that chloride somehow is going to split if there's a reaction, and each one of them is going to incorporate itself with the sodium, and the bromide with another bromide is going to come in and join together to form bromine, the R2, if there's a reaction. So on the right-hand side, I could have write the following. So 2 sodium chloride, aqueous, so this is aqueous, and this is just, let's say, liquid, and plus the bromine. If there's a reaction, okay, a reaction, how do you know if there's a reaction? If there's a reaction, well, they better be forming something that were not there at the beginning. So if I found chlorine at the end, if I found sodium bromide at the end, there's no reaction. But I would call this one a reaction. If there's a reaction, it means there's something new. So if I start with the chlorine, but I end up with the bromine, okay, so that must be a reaction. But how do you tell? Okay, so if you start with the following test tube, let's say that has the bromide solution. So add some sodium bromide in here, maybe a few milliliters, 1 milliliter or so. So that's the bromide. And if you add, let's say, chlorine to it. So first, trying to infuse them together, trying to mix them and have them to react if there's a reaction. And then once you give them like you shake them or give them time to mix. So you need to add some sort of an organic layer to migrate, to let the migration of the molecules of either one of them. So if the chlorine remains to be clustered as Cl2, did not break, means there's no reaction, where it's going to be once you add organic layer. So add small amount of organic layer, like saying. So if there's a reaction, which one of them would be found in the hexane layer? If there's a reaction. Remember, so I proposed, so number one, I said, if there's a reaction, which one of them to be found in the hexane layer? The lighter, the organic layer, hexane. The chlorine or the bromine? Would it be, are you going to be found in the chlorine, Cl2, or are you going to find the bromine in the hexane organic layer? If there's a reaction. Remember the first one? Yeah, go ahead.
The chlorine.
If there's a reaction, so that means that chlorine will no longer remain to be chlorine if there's a reaction. If there's a reaction, it has to somehow crack open and split if there's a reaction. If there's no reaction, I mean, the chlorine will just sit there and watch. Will do nothing if there's no reaction. If there's a reaction, the chlorine Cl2 will break apart as chloride, and somehow will figure out its way nearing the sodium. If there's a reaction, the chlorine becomes chloride, but the bromide, the R negative, becomes bromine. So the halide, IDE, halide, turns into halogen. So the bromide, if the bromide, which is no color, so the bromide has no color. So sodium bromide has no color. So the bubble is, you can't tell, but there's no color to that bromide, sodium bromide. But bromide has no color. The negative anion doesn't have a color. But once you mix it with the chlorine, if there is a reaction, it means if you form bromine, it means you're gonna find an hexane layer, the organic layer, that molecule bromine. Because what is the outcome, which is that solution mixture, and then plus the hexane. Well, the hexane is gonna extract, is gonna migrate, is gonna let in the molecules, which is whatever that surviving molecules. If that chlorine molecule did not survive, it means it breaks apart as ions. It doesn't survive, would not be migrating into the hexane. If the bromine formed, it means it is going to somehow migrate into the hexane. So it depends on the color of that hexane. So if the hexane produces this color, so if the hexane produces that color, see that color? That orange color, that rusty orange color, what does it mean?
It means that there is a reaction.
There's a reaction, because whatever that inside that top layer, the hexane layer, is the color of the bromine, is the color of the chlorine, clear or hint of yellow versus rusty brown color. So if there's a reaction, it means that color in the organic layer is going to turn into orange color. Okay, makes sense? All right. So the bottom line basically is whether or not there's reaction or there's no reaction. Based on that reaction or reaction, the color in the organic layer is going to tell us exactly what's going on as far as the reaction. So let's do the following. Okay, so you're saying, so if I added chlorine to that bromine and the outcome is orange, rusty orange, it means there's reaction, because bromine has that color, that brownish color, brown rusty color in the organic layer. So there's reaction, because I start without any color, and the bromine goes in and ends up in here. Okay, so let's say if you add, so let's say if you say there's no reaction. Okay, so if you say there's no reaction, what does it mean if there's no reaction? So assuming there's no reaction, how? Because what if the end in that hexane layer is a clear color, typically due to that chlorine. So chlorine goes in and then somehow migrated into the organic hexane, and there's no reaction. If there's no reaction, so if you end up with that color, either hint of yellow or clear, it means the chlorine, which is with the hint of yellow or clear and enter the solution, exit out, and no reaction. If there's a reaction, the outcome is different. So this is no reaction, this is reaction. This is the addition of chlorine to the bromine. What if you added chlorine to sodium iodide, for example? Any question about this reaction? How would you tell them apart? How do you tell the difference between the chlorine versus the bromine versus the
Let's see.
the iodide? So assuming instead you have iodide, sodium iodide. Start with sodium iodide. So here's the halide, I negative, and here's the Cl2, the halogen. Now that addition, okay, if there's a reaction, it'll attain the following color. If there's a reaction, it means, so that is no longer bromine, is on that sodium iodide. So that will turn to be iodine. If there's a reaction, right? If there's a reaction, sodium with the chlorine is going to make sodium chloride, then iodide is going to come and join another iodide to make iodine. So the halides, iodide, I negative 1, will turn into molecular iodine if there's a reaction. And if there's a reaction, so when you add that yellow or hint of yellow or no color, almost clear, which is the chlorine in the water, if you add it to that unknown thing, and that unknown thing, upon adding the hexane layer, produce that color. So remember that color. Very unique color as far as the outcome. Okay, so that sort of a pink background color, indicating that unknown must have been iodine. And there's a reaction. If there's no reaction, obviously, here's could be the alternative. If there's no reaction, let's say if you add chlorine, versus no reaction. One more time. So this is, so on this side, on the right-hand side, from your point of view, there's reaction. Why? Because I've added clear solution, the chlorine, into that unknown, and then I've added the hexane layer, and I end up with that pink color in the organic layer. So there's a reaction. If there's no reaction, I mean, the chlorine were made to be chlorine, would not break apart as chloride. Were made to be chlorine. What does it mean? When you add the hexane, it's going to somehow migrate into that top layer. Hexane is going to show this color, clear. Okay, so there's no reaction, this is reaction. Makes sense? So you can readily tell them apart quickly, whether or not you have, whether or not you have iodide, whether or not you have bromide. If you have bromide in the solution, add the chlorine water, what's called the outcome, orangey, to rusty color. If your unknown turns out have an iodide, and there's a reaction, if you add the chlorine to it, what must have been the color in the organic? Pink color. What if you have sodium chloride? So let's say you have sodium chloride. And then how that test of sodium chloride with the chlorine water is going to do? Will it tell us anything? Because the chlorine itself, okay, is kind of clear. Depending on how many times that bottle has been opened, and your fans perhaps forgot to cap it. So how much of left of that chlorine in that water somehow will tell the color. You can tell by the color of that chlorine in that bottle. So assuming there's a small amount remaining, so you can either detect that color, that hint of yellow, or sometimes you can tell them apart, means most of it evaporated. But that solution, to be added to that sodium chloride, which is clear solution, and the outcome is, once again, is clear solution in the hexane. So if you add hexane layer, and the hexane layer, as the organic layer, has that color. So if you add a chlorine, and you mix it first with the unknown, some kind of unknown solution. So I have sodium iodide, I have sodium bromide, I have sodium chloride, unknown. So you add the chlorine water to it, you mix them together first, then you add the hexane layer, and you mix them. If the outcome is clear, what does that tell me? Well, I guess you must start with that chloride. So that unknown must have been chloride. If the unknown is bromide, the top layer, the organic layer, will turn into orange rusty color. If you have iodide, the top layer will end up to be pink by the addition of the organic. If you start with chloride, the top layer is clear. So it turns out chlorine test is conclusive. You can quickly tell which halide do you have. Do you have chloride, or bromide, or iodide? So let's see that with this reaction. Okay, so I'm going to keep that as the background to go back and check. And I want to, which is the last test. We're going to check on that last test, the halide test. Let me see. All right, so from that halide test, okay, hopefully you can see it. So I'm going to keep them in the background. I want to start with the pre-test tube. So let's see those pre-test tube. So definitely, so that test is specific for the halides. Okay, so the last test, which is known as chlorine water test, is specifically halide. I mean, you can check with the other polyatomic ion. That would be no result. Okay, it is only specific with those colors, only true with the halide, and would not generate anything as far as the polyatomic ion were made to be clear. Okay, but you can test it if you want. So, but I'm trying to avoid wasting more chemicals. All right. So, okay, so it doesn't matter. So I guess we can just add them. Okay. And plus, I need more testing. Okay, just to see for the heck of it, I guess. All right. So I'm gonna add the same thing, same setup, and I want to add. So let's have how to add the unknown. So I want to add unknown 1 on this side and unknown 2. Then you just them right in the middle. So you follow me? So I'll be replicating the same thing. So I'm going to add my halides in here, chloride, bromide, iodide, carbonate, sulfate, phosphate. I want to add unknown 1, unknown 2. Add enough of that too. Let's see how it's going to work. So the same thing, I want to add the halides. Okay, so I want to add, so the chloride. Let's figure it out. Okay, so the chloride. Then I want to add the bromide. And then I want to add the iodide. All right, so for the other 3, I want to add the carbonate. Carbonate. Next, sulfate. And the last one is phosphate. Phosphate disappeared. Said it. Okay, phosphate. Okay, phosphate. Sodium phosphate. All right. So I've added all these polyatomic ion, carbonate, sulfate, phosphate. So I want to add unknown 1. And then unknown 2. This unknown 1, unknown 2. All right. The next step is for that test, first you want to add the chlorine water. So the chlorine water addition, basically just a few drops. So a few drops of that chlorine water on all of them, and then mix them. And then I want to add, so and then I want to add, after the chlorine water, I want to add the hexane layer. So the chlorine water, addition of the chlorine to the chloride. Okay, so that's the color of it. I want to add chlorine to the bromide. So make sure you mix them and make sure they're mixed. So that's the color. And I want to add chlorine water to the iodide. All right, so the other ones, so chlorine water. Let's see my chlorine water. Okay, so this is the outcome. Chlorine water. Okay, that's the outcome. So these are polyatomic ion carbonate and sulfate. And I'll be adding chlorine water. The phosphate is the chlorine water addition. I'll do the same for the unknown 1, unknown 2. So I'll be adding chlorine water. and for the unknown 2, I want to add chlorine water. So we're done with that chlorine water. I'm trying to not waste so much of it. I don't have enough to begin with. Okay, so make sure the bottle is closed. Okay, so the bottle is locked. Hopefully, nothing will escape. Okay, so I've added chlorine to all these tests. So the first set are the halides. These are polyatomic carbonate, sulfate, phosphate, unknown 1, unknown 2. Now I want to add the hexane layer and mix them. So addition of the hexane layer is going to give us sort of an outcome. Based on the outcome, want to interpret whether or not we have fluoride, bromide, or iodide. So let me add hexane layer. So here's the hexane layer addition. There are 2 layers. You can tell them apart, right? So I can just mix and make sure they're mixed. Okay, but I mean, you're meant to tell them apart. So the 2 layers, they're meant to be isolated. And here's the color of the hexane. The top layer is the color of the chlorine in the hexane layer. So I want to add hexane layer to the second one. So let me mix it. I don't want to contaminate that solution. So I'm going to mix it. Just 1 second. So here's the, so I want to cap them a little bit. Okay, so let's react. So I got bromide, and I've added chlorine water. So let them react first. Then I want to add hexane layer. So just make sure. Hexane. This. More drops. Okay, so hexane is a little more obnoxious as far as the smell. So this is the outcome. Okay, so I just let me cap it one more time. Okay, so this is what I got while mixing. Okay, so this is the addition of the hexane layer to the fluoride. Rob added chlorine water, then the hexane layer, and I've done the same here. So obviously, so you can tell them apart readily. So that's the outcome of the addition of hexane layer. So somehow the hexane layer, the top layer. Okay, so in this part, the hexane layer exposed the bromine. Remember, they start when I added bromide to the flowing water. It has that look first. Upon addition of the hexane, somehow there's sort of an orangey bromine, then forming and migrated into the hexane top layer. So I identified that color as bromine, Br2. Br2 exists in the organic, it formed because I start with bromide, Br negative. And that Br negative join another Br negative to form Br2. Br2 organic or molecular, loves to be or like dissolved like rule. So it migrates into the top layer, the hexane layer. It has that color. Similar to that control set, which is the metal 2. Now the iodine, remember the iodide? So the iodide, all what I've added basically is chlorine, and there's nothing, there's clear color. Let me add the hexane and mix them to make sure without contaminating anything. So I want to add a small amount of hexane. And the smell of it is not so pleasant. Let me just cap it. Want to mix it? this is what I got as far as about the addition. I don't know if you can tell them apart. So this is the background. Do you see that pinkish background? Sort of it's too faint, but I guess can you tell it? Can you see it?
Yes.
You see that pink background? So I can compare with that rusty orange background. So the rusty orange is the outcome of the bromine. They are moleculars in the organic. The pinkish background, which is attached to the right-hand side, is the outcome of iodine. So iodide, I negative, turns into I2, iodine. So this iodine in the hexane layer is the bromine in the organic layer. This bromine, and this is iodine. Bromine, iodine, based on the color of the organic. The organic layer, the case of chlorine, is clear. So I'll do the same. So I'll be adding, oops. Okay, so this is also expected background. Okay. Yes, I tainted my, so I've done some chemistry. All right. So in here, I want to add the same. So I want to add the hexane layer, see the outcome. So hexane layer, and mix them. I guess because of that, that tab that I've added. So there's nothing. Okay. So the outcome basically clear, except the obvious two layers, top organic and the bottom aqueous. That sulfate polyatomic ion, I want to add hexane layer and mix them, and the outcome remains to be clear. So I would anticipate negative for the case of polyatomic ion. Okay, so the polyatomic ion, carbonate, sulfate, and phosphate, the outcome is clear, as obvious. Now I want to do the same for the unknown 1 and for unknown 2. So for unknown 1, I want to add a hexane layer. And mix it. Okay, so addition of the hexane layer, and here's the result. So obviously, if you check them versus the control set, so which one matches? So here's the control set, and here's the unknown 1. Okay. So this is the unknown 1. Now I want to check unknown 2 for the same thing, which is for the hexane organic. So if you drop some hexane, and here is the unknown 2. So this is unknown 2, and this is unknown 1. They both clear. Both of them are clear. Okay, so this is unknown 1, and this is unknown 2. Unknown 1, 2 together. Okay, no difference. Remain to be clear. Okay, so negative. Okay, so this is the last part, and you should be able to, at this point, you should be able to figure out the unknowns. Okay, so right now we covered page 74, which is that sheet. That should be analyzing your unknown. Now, I'll have to, when you go home, because it wants you to analyze your unknown by yourself on your own. Okay, so based on results, so we have those columns. Okay, so just look them up based on the column that we have. So as far as unknown 1, unknown 2, whatever that in them, whatever that written in them, as far as clear or cloudy or what sort of color your solid first developed, then it disappears, whatever that written per column should be matching one of them columns. Got 6 of them. Okay. So unknown 1 could have been 1 out of 6. Okay. Could have either halide or polyatomic ion, the same as unknown 2. There's only one negative ion, one anion of unknown 1, unknown 2. But that column should be exactly a good fit, a perfect fit of either one of these 6 columns. Okay, so if the last column for unknown 2 matches, let's say maybe 3rd or maybe 4th, it means you have that polyatomic ion or monatomic ion. Make sense? So that column should be fit exactly what you see on around those 6 columns. And that's how you identify the unknown. Now, The activity for tonight basically is done. So what's left is go on, identify the atomic ion. Okay, so they're just write down. So this is unknown 1, unknown 2, and just identifying. So whether or not you have, let's say, chloride or bromide or whatever the hell, I write it down. If there's atomic ion, write down the formula. So write down the formula for unknown 1, write down the formula for unknown 2. And then there are a few questions. So I'm going to leave those questions to you. But then the last part, question 4, it'll ask you to write down the net ionic reaction. So there are 2 questions pertaining number 4 question, A and B, which is how do you write down the net ionic reaction? Let's do an exercise. So let's assume we have the following. So now we're going to practice or memorize or trying to remember the how do you write down the net ionic reaction. So let's assume the following. So let's assume that we have the following 2 solutions. So let's say we have. So I'm not going to do exactly those 2 questions and leave them for you guys to practice and do an answer. But then I want to do something different. Let's say, assuming I've added barium chloride. Remember the barium test? Let's start with barium chloride. Why is it so positive in case of, let's say, sodium sulfate? Remember? So I've added that barium chloride and I call that test barium test. Barium chloride test. So that been added to the sodium sulfate. Let's see how that test is positive. So if this is positive, means there's an outcome, there's a product, and that product does not resemble any of these 2 reactants. And that product turns out to be barium sulfate. Barium sulfate is a snow white solid. So this is solid. So when I start worrying about the subscript, barium chloride is a clear solution, no color, transparent, but it is clear, no color. Transparent basically is you can just shine light and you can see the light going through. If it's clear, okay, so there's no color, 2 colors. Sodium sulfate is the same, clear and transparent. So this is aqueous. Okay. If there's a reaction, there would be something that was not there. So I've just miswritten the barium. So it's barium sulfate plus the remaining sodium chloride. So trying to practice or memorize or remember what gone on for the lecture in terms of writing the net ionic reaction. So first, step number 1. Balance the given reaction. Okay, so first, propose that there's a reaction. I don't know if there's a reaction or reaction. Just continue on writing the right-hand side, such as come up with something different than whatever is written in here. So that's the proposed reaction. Could be a reaction, could be no reaction. I don't know. But if there's such a reaction, I guess the 2 positive and negative will swap places. And will turn out to have barium sulfate if there's a reaction and sodium chloride. All right, step number 2. But make sure that step is balanced. Balanced in the first step is called molecular reaction. When we balance the reaction, we call that balanced reaction molecular reaction. The second step is write down all these components and compounds as ions. Barium chloride aqueous, so I'm going to split it into 2 ions. Barium plus 2 plus 2 chloride. So I want to just split into its ion. Okay, and write down, follow up with that subscript aqueous. And mimic exactly all these steps for these A and B for question number 4. I'll continue with the second, sodium sulfate. Sodium sulfate. So by the way, how would I know that barium chloride will be written as ions? So there's a table when we discuss these solutions. So look up that solubility table discussed in that particular chapter. So look up that table that shows solubility and the outcome of having, let's say, positive ion, negative ion. This is barium is positive ion, the chloride is negative ion. Do I form a solid? So that table is titled with solubility outcome of adding positive and negative ion. Would I form a solid or would I form aqueous? All right, so the outcome of that basically is ions, would not form a solid. So breakable into ions, the same as the sodium sulfate. So I'm going to write down sodium sulfate as 2 sodium ion plus S4 negative 2. And follow up with that subscript, aqueous, this aqueous, and this is aqueous. Now the product, okay, so the first product is solid. So keep it together as solid, leave it alone. Barium sulfate, solid. So if you end up with forming a solid or gas or liquid, okay, so they would not be broken apart as ions. So always solid, liquid, or gas, if they happen to form as the product, keep them together, not break them apart as ions. Only break apart the ions based on that solubility table once again. Sodium chloride is breakable based on that table soluble. For example, if you end up having silver chloride. Okay. So not because for the fact royal chloride typically is negative ion typically and silver is typically positive ion, but that itself, that combination is still a solid. How would I know? Go back to that table. That's what I'm trying to say. Do not predict. Just go back. The reference point is look up that table, solubility table, as a reference point to tell whether or not these two positive and negative ion, while dissolved in the water, are breakable as ions. Okay. So don't guess it. Okay, so this would not dissolve in the water. Remain to be together as particles, solid. Okay, so this is breakable as 2 sodium ion and 2 chloride ion. And continue with the subscript right up. So 2 sodium ion aqueous, 2 chloride ion aqueous. So call that step the ionic reaction. First one is molecular. So it's called molecular. This is known as the molecular reaction. Second is ionic. Now the third, okay, is the outcome of canceling things in the ionic. So if you see anything left or right, okay, if you see similar ions, similar things to be canceled left or right, take them out. You see anything could be canceled or dropped. Remember the chloride? So I've seen 2 chloride ions and the same thing, the subscript matching. So it needs to match the number, the ionic assignment, the state, aqueous. If there's something in here, aqueous, some other, so it needs to carry exactly the same value, left to right, take them out. We call them spatial ions. Now I've seen sodium and sodium. They match the number, they match the write-up of that sodium. It's a sodium ion positive, and then the state of it, which is aqueous. So if you see that matching left to right things, take them out, and write down the leftover. So write down the leftover, what's left in that reaction is barium ion, 2 plus. So this is aqueous. Plus sulfate, aqueous, producing barium sulfate solid. So that reaction between those 2 compounds, and it has how many components? There are 4 different ions. Not all of them reacted. Okay, so they exist. Not necessarily all of them should react or exchange each other as far as this is what we're claiming initially. So those partners, the sodium, hop in and replace the barium hop in and replace the sodium in its own solution, and that's how they swap. Not necessary. What turns out to be the true reaction is only the barium comes in closer to that sulfate and producing that barium sulfate solid. That's the only reaction. The rest of them are just sitting there and just watching. Call them spectator ions. Okay. So that's the final true solution, true reaction that would occur between the barium and sulfate. So the last reaction, last step, number 3, is called the net ionic. So it's called the net ionic. So question number 4 is asking to write down all the steps of the net ionic reaction. So start by asking you, so for A, so based on that first reaction, balanced reaction, before that molecular, write down the net, but don't guess it. Always look up that solubility table in your textbook. And then lastly, cancel out spectator ions, the ions that are shown left to right, and write down the leftover. Okay. If there's any leftover reaction to be written, then there's reaction. We call that reaction. If there's any leftover, we call that reaction that is leftover the net. If there is no leftover, assuming I've written the right-hand side, the left-hand side the same, and I cancel everything. Is there a reaction? No. Once you cancel everything, there's no reaction. Okay. But this is just a practice. So that example that I've proposed basically just practice. For your case, basically you want to write down. No. So I've done one of them. Okay, so I've done B. So my example turns out to be the same as part B. So you're left with part A. So silver nitrate and sodium iodide. So practice with that example, which is I've solved or I've done barium chloride with sodium sulfate. That's pretty good, very nice view. So now what's left to be done basically is part A, or part A. And figure out or complete that table of the unknown. So that table that asks you for the unknown. So figure out what's the unknown and finish out questions 1 to 3. Any questions for me? Any questions for me?
Okay, so
All right. Is there any last minute question?
No, thank you.
There's no question. All right. So everything's clear.
oh yeah. So
Hopefully.
let's see. I understand how to do the net ionic equation from the complete ionic equation.
All right. Is there any question about it, or everything's clear? So based on the example that I've done, so basically I've done without without anything. So this done part 4B, so it's done for you. So just based on what I've done, all the steps. So trying to mimic exact those steps that could occur to that reaction, 4A. So that's what's left for you to be done, and identify those 2 onions. Okay. And some of the letter board 7 o'clock next week. Any question for me? Any concept? Anything that you want to go over, or any question? If you have no question, I guess you guys have a great night and see you next week.
Have a great night, Professor.
Thank you.
Okay. Have a good night, Professor.